In this course, we will try to use a standard unit for the cost of energy, dollars per gigajoule. Energy is marketed in lots of different units, and you will need to learn to convert them into one standard so you can make sensible comparisons between them. For example, many industrial boilers or electricity generating stations can run on either oil or gas, so they will choose whichever is the cheapest. So if oil is, say, $60 a barrel and gas is $5 per million BTU, which is cheaper? Have a look at the conversion tables and get used to making quick conversions using simple approximate rules. For example, a barrel of oil has about 6 gigajoules of energy, and it helps to know that a British thermal unit is almost exactly 1 kilojoule. In our example then, oil is $10 and gas is $5 a gigajoule. So in an even competition, a consumer would always choose the gas. We will also use a standard unit for the capital cost of devices that convert or transform energy. That unit is dollars per kilowatt of capacity. This is the amount of money it costs to buy a device that transforms energy up to some rated maximum power capacity. For example, a nice 1 kilowatt electric motor costs about $100, while a 10 kilowatt motor costs about $450. So here, as is common, the cost per unit of capacity decreases as the unit size increases. First, you need to be able to make pure physical science unit conversions, like switching between cents per kilowatt hour and dollars per gigajoule. Second, you need to be able to convert between units in which energy commodities are commonly sold and some standard unit like dollars per gigajoule. This conversion is not a simple unit conversion because it depends on the energy content of various fuels. The amount of energy in a barrel of oil or a ton of coal is measured in heating value, the amount of heat, enthalpy, produced when the fuel is combusted. Note that not all kinds of coal or oil are the same. Different ranks of coal have different heating values. Lignite lower than 20 megajoules a kilogram, typically less than dry wood, while anthracite, the best coal, has an energy content over 25 megajoules per kilogram. Finally, one frequently needs to convert different measures of energy flows or consumption rates. In physical science units, the rate of energy use is the watt, a joule per second. Energy flows are often measured in quantity per year. For example, in 2014, China used about 4 billion tons of coal per year, and the global oil consumption was about 90 million barrels per day, about 1,000 barrels a second. To compare energy flows, it's helpful to use standard units, typically either watts or joules. For example, global energy consumption is about 15 terawatts, equivalent to a per capita annual consumption of 70 gigajoules per year.